Right, now we're being asked here to find which of these lines are parallel. Now we've done a bit on equations of lines and stuff, and we should recognise y equals mx plus c. Now, if you remember this is a general equation for the equation of a line, and the m bit, the number next to x, is the gradient. The c with parallel lines doesn't really matter actually, so that is the gradient there. So if we can get all of these equations into this form where we get y equals mx plus c, then we should be able to tell which ones have the same gradient or the same slope, and therefore they are parallel. So this one is already in the form y equals mx plus c, and the gradient of this one, the gradient is what? It is 3, because 3 is the number next to x. This one isn't quite in the form of y equals mx plus c. I've got two y's, okay? So I only don't want two y's, I want one y. So what I've got to do is divide everything by 2. So I've divided that by 2. I get 3x plus 3.5. Now don't be alarmed by the 3.5 bit. You can have that, it's not a problem at all. So the gradient of this line is also, and I'm going to underline it, 3. Now then, again, we're going to have to do some rearranging here because I haven't quite got it in the form y equals mx plus c. I've got y plus mx equals 8 or whatever in that sort of theory. But I want y equals and everything else on the other side. So I need to get rid of this bit here. It's plus 3x over there. So when it goes over the other side, it becomes minus 3x. And that 8, I'm going to tack on the end. Now it's in the form of y equals mx plus c. The gradient, now be careful here, is minus 3. Okay, they'll throw something like that in there to try and put you off track a little bit. Now this one, unfortunately, we've got everything on one side. So we're going to have to do a couple of stages here. I'm going to put everything else on the other side and leave the y bit on over here. Okay, so when this goes over to the other side, I end up with 12x. When this goes over the other side, I end up with minus 7. Okay, now I want 1y, not 4 y's. Divide by 4, I get 3x. Divide by 4, I'm actually just going to call it 7 over 4. You could call it 1.75. Doesn't really matter. So the gradient of this one is also 3 because it's 3 x's. Now, which ones are parallel? Well, it's the ones where the gradients are all the same. So this one is parallel with this one and this one. Okay, this one is not parallel. In fact, I'll put a line through it. That's not parallel because the gradient was minus 3.
Okay, Mary, so let's have a look at this one. So solve x plus 2x equals 12. So what do you think you do first?
Okay, well, I want x on its own, so I would put x equals 12 minus 2x.
Okay, so a lot of the time we want to get x by itself, but what we want to do first is get all of these x's together. So can you see anything we can do with this? Get all these together in one place.
Oh, okay, it's 3x, isn't it?
Yeah,
so
absolutely.
3x equals 12. Oh, and so x equals 4.
Brilliant, spot on, well done.